Okay, should we start? So, maybe let's just talk about what we're gonna do today. Hopefully it will not take 3 hours, we'll see, because it's the first time we're doing it. Hopefully it will not, although it's pretty kind of rough on the edges at the moment, the whole thing, so if I get stuck or something stops working or something, just bear with me, because we haven't done 3 hours workshop before. So the first, it's kind of like, it's not only a Webdriver workshop, we're doing it as part of this kind of test engineering guild in the DevTools family, and there's a first thing we'll do is to show you some slides about what we think is it's like a test pyramid, which reflects how tests, different kinds of tests should be written in the products and how they should relate to each other. So that will be like a more general introduction of where Webdriver tests fit in the bigger picture, and then we're gonna go into details about Webdriver tests. And first I will kind of go for a little bit of theory. If you haven't written Webdriver tests before, it may be sometimes not, or if you haven't written a lot of them, it may be not very obvious what I'm talking about, but then I'm going to show some examples, and we're going to go through an example from the DVCS connector that will hopefully be more kind of a concrete example of what I'm talking about. Apologize for showing my back to some of you. I found it the most comfortable position to run it. Okay, should we start? Any questions before we go? Okay, so first, this kind of the kind of common set of slides about the different kinds of tests we think we should be writing for our products. This is just the quotes. By the way, I didn't put together those slides, so don't blame me for them. I think that, yeah, this is an introductory quote to just get you excited about writing tests. And this is agenda for this first part, which really there is no practice for that. I'm just going to go through a bit of a theory. Objectives is when to write the right test, basically. So next time you're writing a feature, instead of just like following something that is already there in your plugin, which maybe not, or in your project that maybe not necessarily the best approach, you will maybe stop, think a little bit of what's the best way of testing different aspects of the feature you're adding. So yeah, theory. So this is basically a test pyramid that we came up with. It's still kind of being discussed, and some aspects of it maybe change, but generally we think there's those 5 layers of tests, and kind of everything that every test we write in Atlassian will fall into one of those. And the pyramid, I guess you may have heard, like if you're interested in the kind of in testing, you may have read some blog posts and stuff. It's not a new concept. It's generally accepted concept that like the bigger the layer, it kind of reflects the coverage and the amount of tests you should be writing of this kind of type. So like obviously unit tests should ideally cover like 100% or close to 100% of your code, and then component tests, as we go up, the coverage is a bit lower, and the areas of focus are a bit more narrower. So I'm going to talk about those different layers over the next slides. I'm not going to try to explain them at this particular slide. That's yeah. As I said, it's not something we invented at Atlassian. This is some other test pyramids out there. The one on the right, I think, is from Uncle Bob, who's probably heard about Uncle Bob. He invented, what did he invent? Well, he was one of the agile software development guys, and he wrote the book Clean Code and invented a lot of, or at least promoted the extreme programming, I think, whatever. So that was his pyramid, which is kind of similar to ours, except that it includes exploratory tests, exploratory tests are usually manual tests. The pyramid we have is just purely for automated tests. We don't put in the manual part of testing either. And then Martin Fowler, obviously you probably heard about him as well. He kind of has a simpler version of it, just unit, service, and UI. And then this is to demonstrate anti-patterns. That what often happens in projects is the inverted pyramid or the ice cream cone. So that's something we want to probably try to avoid, although it happens in our products and projects as well. You may have questions, where does performance testing fit in, or where does, I don't know, some other kind of test that we have fit in that you haven't seen that pyramid. Like the pyramid is mostly showing the function, like it's mostly about functional tests. All the other kinds of like performance testing is not really functional testing. It's about testing specific aspect of your code, and it's a cross-cutting concern, and it may be using different kinds of tests in that pyramid that I showed. Usually it will be probably either service tests or UI tests, something that tests your application on a more integrated level. So yeah, that's just to explain if you have, because often people ask, oh, where does we have this kind of tests, like setup tests, or this kind of performance test or something like that, where does that fit in? And the answer is, if it's not functional test, it's probably fitting, like it's not inside the pyramid, it's a kind of orthogonal problem to the pyramid. And this is so as a kind of common theme for these slides, we come up with this idea that there's some feature under test, and in our case we will be demonstrating this based on the login feature. So basically a simple login screen and all the logic behind it. So basically assume you were asked to implement that feature, and then we'll go through different kinds of tests. How would you approach it? Okay, so unit test, that's the lower layer of the lowest layer of the pyramid, and obviously when to write it, the answer is pretty much all the time. For pretty much any feature you will write code, like small units of code, and you want each unit to be tested. Just keep in mind, unit tests, it's not only Java backend tests, but also JavaScript unit tests fall into this. So if you're writing JavaScript components, you probably want to write unit tests for them as well. So what's the scope? What's the focus of a unit test? Obviously, unit of code. So in most cases in Java, it would be a class. In JavaScript, it would probably be one kind of AMD module or something like that. If you do TDD, which we don't do a lot in Atlassian, but if you like it, then you would probably write a test before you write your code. But that's not something we require. I think it's perfectly fine to write some kind of service or component or whatever you're writing, and then test it, write the test after. I guess you probably want to push or commit your tests at least together with your production code rather than after the fact. And then another case, often if you have a bug to fix, that's actually a pretty useful practice that I personally often do. You would write a unit test before to expose the bug, to kind of demonstrate clearly that there is a condition that shouldn't happen, and then actually write a fix to make the test green. And obviously this avoids regressions in the future, at least the same kind of regression. Next one, so how does it look? How does it apply to our login feature? Say we have some kind of login service that that validates the login or the username. Obviously, you would have some. This is actually wrong because this is for sign-on, not for login. But obviously, say you would have to validate that the password is actually that the username and password match, and I don't know, whatever error conditions can happen during the login. If there is a CAPTCHA kind of service involved, you would probably check whether the username is not captured and so on. Component tests sit kind of above unit tests. So what component tests are basically, like with unit tests, there is no notion of integrating anything altogether. So there's a very simple component. If it has any dependencies, you want to mock out the dependencies and just focus on business logic in that particular component. With unit tests, it's a bit more higher level test. So you kind of integrate parts of your application, but your whole application is not really running yet. So the most common examples of component tests, like in the backend, would be, for example, DAO tests. So if you have any kind of data access objects in your application, like in our products, it would be mostly Hibernate based. In our plugins, it would be mostly active object based. You need to kind of instantiate some parts of your application context to have access to the database. Like for example, in Stash, it would be instantiating part of the Spring context that manages access to the database, and then instantiating your DAO, and then injecting actually those real, not completely mock dependencies that actually connect to the database to run your tests. And then in your builds, you can swap the database, and you can run your DAO tests against different databases to make sure it kind of works across all your supported databases. So basically the rule of thumb is you kind of instantiate a number of components, parts of your application, and then you instantiate the component that you want to test, and you run your tests. So usually they're a little bit probably slower than unit tests, but like the focus on edge cases or like all the corner cases of your logic is still really high. So you want to cover, you want to have a pretty big coverage again, what else? But then the not as big coverage as unit tests. Like you don't really need to test everything, because presumably you already tested some parts of it using unit tests, and you just want to focus on the parts that can break in that bigger integrated scenario. Also in front end, I guess that could involve, we're still talking about it, but like an equivalent in front end would be like if you have a dialog. So like unit tests in JavaScript would probably not interact too much with the DOM and the UI, because it's kind of stops being a unit test at that part. But component test could be like testing a whole dialog, and for example maybe simulating some UI actions and seeing how the dialog responds to that. So that's component tests. Then we have that's the example. Yeah, again, that's the login feature. So I guess in the case of the backend, the classic example would be have actually instantiate the DAO that stores the user data, the passwords, and the usernames, and test for different cases whether when the password matches the username, when the password doesn't match, when there is no username in the database, and so on. So to test how it does work actually against a real database. in front end, I guess, yeah, you could if you have a component that, like, if you have a front end component that, say, talks to a REST endpoint and just this, like, rather than reloading the page, you could probably have some component tests around that it displays proper error messages and stuff like that. Next layer is service tests. So service test is the first layer where you actually integrate your whole application and running some tests against your running application. So a typical example would be REST tests, for example. So if you're testing your REST APIs, you need to start up the whole Jira or Stash or whatever, and then run your tests against it. I would argue also that JWeb unit tests that we have in Fusion are this kind of tests because they don't really test the application from the perspective of the user. So the JWeb unit tests.
So what is it?
JWeb unit or HTML unit.
Oh,
yeah. So it's kind of an embedded browser inside Java that doesn't support JavaScript. So it just makes static calls to.
Yeah, we don't have the Fusion. It's more Jira. Jira that have it.
Well, didn't you show me some JWeb unit
It's
tests?
in JVM, that's not Fusion.
Ah, there you go. Okay. Well, so at the outer edges of Fusion, we have some of that, and Jira definitely has some of that. And I think some setup code in Fusion plugins used to use that shit a bit, just because it used some Jira stuff. Whoa. Anyway, I think these days the most reliable kind of tool for service tests, or another idea for service tests that we kind of tried in the past is you start up the application and then you actually deploy your tests inside your application, and then you have some backdoor REST to call and to execute those tests. So your JUnit test would be running inside your application, and then it would have programmatic access to your service layer, for example. So you could call your service layer right from inside. But then, yeah, it's still controlled kind of by a REST backdoor to kind of get the test results and stuff like that. But I think these days, just having like a solid REST kind of API and testing the REST API is a really good way to execute those tests.
So do we tend to use JUnit to invoke that, or
well, we use JUnit or TestNG, but in the end you will use JUnit or TestNG to really invoke all those tests.
But we don't tend to use other tools to invoke it completely externally.
Use Maven to invoke JUnit.
Well, we
no, but what I mean is yeah, we don't use like a SOAP or what is it called, SOAP UI, SOAP UI, something like that.
SOAP UI, what?
Yeah, it's a tool for testing REST endpoints.
I guess that's
okay.
What I'm getting at is we use JUnit as the thing to kick off all these different types of tests. Yeah.
Well,
or
from my experience, we do. To me, JUnit is just I mean, it was designed as a unit testing framework, but like it's used for running. It's just a running
general purpose
test.
Yeah.
So like Webdriver tests we run using JUnit.
Yeah.
For example, in Stash we used a framework called REST Assured, and that we also use JUnit to run those tests. So like inside the JUnit test, you can do whatever you want, I guess. Yeah. So either like it's some sort of tool or framework that has to remotely communicate to your application because your application is fully integrated running, and then run some tests that actually end up covering your kind of service layer. So it's obviously different than component tests because it's gonna be much slower. You have to start up the application, and anything you do kind of will interact with the whole stack all the way to the database, except for the, say, front end. So that I'm gonna talk about the next layer where it's even more integrated. But it's usually those tests will be pretty reliable. It's kind of hard to introduce, or it's not hard, but like if you have good tools, good practices around it, they will be pretty reliable and not too flaky. but obviously they will be much slower, so the coverage again will be a bit lower, but I would still say it's a good tool to cover some definitely happy paths, and then a large number of error scenarios. For example, in Stash we use it a lot to test for security, to test whether users with given permissions have only access to given functions or resources in the application. Yeah, as it says, right level to test security. Anything else to add? No, I guess, yeah, that's pretty much the essence of service tests. And then, given the, say, the login feature, if you have a REST endpoint for login, which you may not have, then you could, again, supply some happy paths, good username, matching password, and then maybe a couple of valid and invalid credentials. Perhaps if you have CAPTCHA, or any other, or if you have like the Remember Me feature and so on, that would be a good level to test it. Front end is probably, yeah, it's not really applicable to front end, this kind of test. And the next one, kind of, well, not the last one, but like the highest up the chain is the UI test. So really, what in our case it's mostly WebDriver test. So it's basically end-to-end testing of the whole application stack, starting from the browser. So like basically has the way the user sees it. So starting from the browser, the front end fully integrated with the back end. So the difference to service tests is basically service tests do test the whole server side, the back end of your application, but not necessarily the way browser actually talks or interacts with your server. And again, UI actually is a more broader concept. Like in our case, we're mostly writing web applications, so in our case, UI will mostly mean just browser tests, but for example, for product like SourceTree, UI would mean the actual GUI interface, whatever it is, on Windows or on Mac, just different frameworks. So you would have to automate that actual desktop application to run this kind of tests. But again, for us, it's mostly browser tests using WebDriver. So again, what the extra coverage say it adds is to the part where the browser talks to the server. So you already made sure the server is pretty solid with all your lower layers. You know that all those components work even when you integrate them together, but you don't know whether if you add the front-end logic into the mix, how it's gonna interact with your backend. So I guess the main point for those tests is again they're slow. They're slow because you have to start your application, you have to prepare some data and so on, and then they also tend to be flaky, as you know. So mostly because browsers are, and JavaScript, I guess, engines are complex, and the DOM as well, like the DOM, the whole way HTML is processed, it's a very complex stuff, and browsers are really like third-party things that were not designed to be automated, they were designed to be used by users. So just stuff just breaks sometimes. So one thing is like the actual Selenium, the framework we use to automate the browsers. It has some bugs. It's not always gonna work 100%. And the other thing is there's extra complexity in that you have the server process, you have the browser process, and you have the test process. So you have 3 different processes, and they all run asynchronously to each other. And that makes it very easy to introduce race condition and flakiness of all sorts, as you probably all know. What it all means is we don't want to write too many UI tests. So you always want to think twice whether you want to write or you need to write a WebDriver test for something, or if you need to write, or if you think you need to write, how big the coverage is. So just remember the pyramid WebDriver tests are not good tool. Like if you find yourself thinking, oh, I have to write WebDriver tests to see whether this page or this dialog will show up to a user who doesn't have permissions and stuff like that, then maybe you're doing it wrong, and maybe you haven't provided maybe REST APIs or whatever else that allows you to test it at a lower, more reliable level. So WebDriver, I would start with the assumption that you're just kind of writing smoke tests. So just covering the happy paths, making sure like you can access the application, things just don't break, you don't get 500 like HTTP errors and shit like that. And then there is a, like for example, if you're fixing a regression, like a repeatable regression, and there is no other way to test that regression because it involves front-end code talking to the backend, then perhaps it warrants writing a more kind of edge casey WebDriver test. But generally, avoid trying to like overcomplicate the test scenarios in WebDriver tests.
Can you give examples of what you mean by that from the front end, one of these scenarios?
I don't really have any recent examples for that. I remember in Jira we had repeatable regression with some. I don't really have exact example. Like that just suggests that.
I guess something, maybe this thing about when the front end talks to the back end. I mean, pretty much always.
Well, I guess say you have a REST API that you have well tested, but then you have front end that, I don't know, just doesn't, usually what happens is the front end doesn't, you break something in the front end that it doesn't use the back end in the right way, and then does something unexpected, I guess. But then you could argue that you should have the front end unit tested well enough to make the right calls in the right condition.
But I guess it'd be pretty easy to write a unit test that mocks the back end incorrectly, right? Like you could assume that the REST response is going to be a certain format and the server is actually giving it to you in a different format. In that scenario, a WebDriver test would expose that, whereas a unit test would.
Yeah. Well, so that's basically the classic case where, unit tests will only test your assumptions of how you integrate with your dependencies. It won't actually test how they integrate. But again, I think the approach is always to have a lot of unit tests and component tests for your backend and frontend, and then have a couple of WebDriver tests. Because the thing about WebDriver tests is one test will have, one WebDriver test will have a massive, we will already have a high level but a massive coverage of your code. It will go through all the, levels of your code. So unit tests will be very focused on one component, and you can have very high coverage for different edge cases. And one WebDriver test will go pretty much and make sure, that the response from your server is what your front end expects from it.
But not testing too many scenarios.
Yeah.
Yes.
Again, if you have a regression that clearly was caused by, there was no WebDriver test that test, we expected some response from the server, or server sent some response, but we expected something else in the front end, and we didn't have a WebDriver test for that, then maybe that's where you want to add this WebDriver test. Yeah, and in case of the login feature, I guess it would be just one successful login, maybe one failed login, and just test that it displays the correct error message, and I think that would be good enough to start with. And then cross-product integration tests, something actually that Fusion, I guess, does a lot, but something that I think is still, we are still figuring out some sort of best practices for that and what it means. But I guess the main point is, again, they almost the orthogonal thing in a way to the pyramid as to me at least, as the performance tests are, because cross-product means we have two different applications and we're testing how they integrated together. So a lot of what Fusion does is integrating products. So you want to make sure that, you know, stash, when stash is, I don't know, when someone pushes to stash, it will index all the commits and it will actually send the right events to Jira, and then Jira knows what to call to get that information from stash.
So even like most of drivers in Fusion, they're depending on Bitbucket or GitHub, I think.
Yeah. So the thing is,
Mock,
the tools that you're using here could be, well, like you could be writing service level tests. So for example, if you have a REST API in Jira to get your dev status data, and you call that API, and that actually results in Jira calling stash to get the data from stash or to update the data or whatever, then you have like a service layer integration, cross-product integration test. If you're using Webdriver to actually test the development tunnel, then you're writing a UI cross-product integration test. So it's kind of like, those tests are kind of like either service tests or UI tests, but with the extra aspect that you have like two applications or more connected and integrated together, and you're actually focused on testing that particular integration rather than just a single product functionality.
I think in some cases, for us, the service level cross-app integration would be lower in the curve here, but than the UI tests. I think we would want to have a lot more investment in
so that's
ensuring
why,
synchronization between Bitbucket and DBCS connector than we would, you know, sort of at a service layer than the UI.
So that's why this is still like, I don't even know if it should be part of the parameter, or it shouldn't be just like on the same as performance tests. Like you're using either service level or UI level tools to run those tests, but
I think it does make sense to be separate because, you know, for example, DBCS connector syncing, we could do a lot of that with mocked dependencies using CTK, but then we probably also want to have some that go, you know, we probably want to have the mocked one lower and then the actual integrated cross-app.
So it's very similar in some ways to what service layer is to you, like what is service layer versus UI. So service layer is testing your like the backend, what your backend does, without the actual like just like that it meets your expectations, and then UI adds the front end on top of it. So how the front end integrates. So the same, that the CTK will kind of mock out your external server. So you're actually just testing how your application behaves given some external dependency that you put in some assumptions about, and then you actually replace the external dependency with real dependency. But yeah, I guess in ideal world we would have a lot of those kind of those tests with mocked out external dependencies or external products, and then it's just a small amount of those real integration tests where you're testing both products integrated together. And the way I guess to that is to have really well defined and well tested APIs on both sides, which is not always easy, I guess, or not always the case.
Daraj, you talk about contract-based testing helpful in this context?
I am not going to talk about it, but
because it leads neatly into that, because if lots of products are going to want to simulate, for example, how Stash works, then it would be very useful to have a public specification of Stash's API that people can test against.
Yeah.
And Stash can test themselves against the API to make sure that they actually comply.
Yeah.
So
I guess the CTK server was the kind of our our half.
That's the plumbing of it, but the configuration of the CTK.
Yeah, I mean that was the idea behind it, but like, I guess we don't have a tool like that.
So Andrew, I think that will be one of the next focus areas. So we're going to focus on Webdriver first, and then like integration testing and Spark and CTK will be one of the next.
Okay.
Yeah. So again, this is like very early stage of our thinking, I think, especially on those higher level things like cross-product integration. So for now, we've just figured out, okay, there is this special case, but we're still thinking what's the best practices for that. And yeah, some ideas how it would fit into the login feature. For example, if you had if you delegated your authentication or user base to crowd or LDAP, then you may want to run your login tests or your UI tests against a real crowd or real LDAP. As I said, there's no practice for this, and there's no summary and no questions.
Questions allowed?
Okay, we don't have questions. You may have some questions if you want to ask anything, but I guess we kind of were answering some questions as we went. Again, this is just introduction that we're gonna run to every. I guess the idea is we're gonna go with this to every product and to every team and run it before we run the actual session on the actual tests. So it's just to, so you kind of have an idea where the Webdriver tests fit in the bigger picture.
So now that you've told us to almost never write Webdriver tests, you're going to tell us how to write Webdriver
Now
tests.
we're gonna spend 5 minutes.
Well, we have a lot of them already. So with that,
I'm gonna show you how to remove them. There's a delete button in it.
sorry, with the crowd LDAP example that you just gave at the end,
Yep.
that sounds like a good application of service tests rather than UI tests, because
Yeah, that's true. Yeah.
the UI
So
is identical.
So again, you could take your service tests and just, configure an environment to run them. Yeah, I think that's a good idea. Yeah. So again, that's what we talked about. It doesn't have to be UI test.
Yeah. And also just a quick one, why it's at the top of pyramid, it talks about coverage, not necessarily why at what level of the stack you test in the stack. Right. So the idea is that you don't test many scenarios when talking to real applications, because really you should be trying to do that using Moxo on a service level and spin up end to end, just few smaller things.
So a CTK test that snubs out another application would be in the service layer. That's because you'd have lots of coverage at that level compared to just using a real application.
Okay. So that's.
One question. Is there any case in which you would have a distorted pyramid? Like, for instance, I assume the reason why there's a pyramid, right, is because there's the assumption that, the connection of, the UI with all the components and what have you is, there's assumed that if it works once, it will work every time, or if it works a few times, it will work every time. Because every single scenario that the application can do is, unit tested. So, is there any case where the pyramid would not be that form, and that you would want to have more UI tests than normal?
Well, I think from my experience, it's only the case if you have a badly designed code. So if your code doesn't allow you to, I've seen a lot of code bases where you just can't write unit tests because it's just not designed to be unit testable or to even be component testable, because you cannot start parts of your application. So I think most of the scenarios where in real world where it happens is because it's just been done wrong from the start, I guess.
That's why you need to write your code and test together, so then make sure it's testable.
So it's not something that you
Some people
would
don't
want,
know that.
but it's somebody where you can end up in.
Yeah. So it's not something that you would plan for probably. Although I think Łukasz or someone posted in a link to some blog post about how they have 10,000. I haven't read it actually. Have you read it?
Yeah.
10,000.
It was I think it was mostly the case on a project where you had a lot of data, you don't have any tests. It was easier to start with a lot of UI tests and sort of create this cone shape, and then slowly over time turn this back into pyramid. It's kind of like if you don't have anything, it's better to have at least cone than nothing at all, and then kind of try and move to the pyramid.
Because the UI tests protect you against breaking things, because if you can't write unit tests, you've got to refactor everything, pull it apart into
But that assumes that your UI tests are maintainable and reliable. There's those two things about UI tests, or any tests. Reliable is it's not going to break randomly without any changes. Maintainable is it's not going to break because you introduced some other completely unrelated changes. And the problem with writing UI tests is it's pretty hard to write maintainable and reliable UI
And
tests.
fast,
So,
and
yeah. So, and then if you end up with, you know, builds like Jira has or whoever other products in Atlassian where your builds are read every, you know, every second build because there was some test breaking, because whatever, because it's unreliable, then the value of having those tests is much lower. Because what confidence does it give you if it just breaks all the time and takes people time to fix and stuff? So there's a balance.
Yeah, more
trade-off.
the more UI tests, more chance of having flakiness as well. So that's hard.
I think the last argument, like the higher level your test is, the harder it is to localize flagship problem. Like, because basically the test will tell you somewhere in this stack something failed,
Yeah.
and go and find what exactly failed.
So that's the other thing. As you go up the pyramid, the kind of errors you can, like with one web unit test, you can catch a very limited amount of problems because it's very focused. With one WebDriver test, it's like the opposite. It's very broad. Like you can run WebDriver test and it will catch errors anywhere in your stack. But then the error you will get, the message you will get will be like, will make you spend 2 hours investigating what actually broke. Whereas if a unit test breaks, you get a very focused feedback of what's wrong. So that's the other two kind of aspects. As you go up, the focus is getting like broader, but also the kind of error feedback you get is much less informative.
So a good example of the ice cream Barbie thing is the VCS connector code. Lots of WebDriver stuff, but not much about unit testing. So
A bit of hourglass or something. Lots of unit tests and lots of UI tests and not much in the middle.
no, there's not much. Not much unit tests actually.
Yeah, and the other thing.
If it's there to allow you to do refactoring. So if you have like a really nice story and it's, you know, it's fit the story, but all these UI tests to protect you that this is what's going to happen, then you can happily refactor a lot of your code and then change your unit test. If you don't have a lot of UI code, as soon as you refactor all your unit tests break. I mean, what you're doing might be technically correct and logically correct, but it's just as you move classes around, all your unit tests going to break. So the UI test it's very valuable in that perspective. But it takes a long time to run. So that's why people hate it.
But yeah, the other thing is also maintenance cost. I always, we always, like, it seems like everyone is just like, you know, we have to add more tests and like every feature we just writing whatever tests we can, but then I always tell people to consider what's the cost of the test. Like I see a lot still tests, especially like UI tests have a big cost, big maintenance cost to them, like implicit. Like there's so many things that can break or change in between that like your UI test will just break and it will cost you more in maintenance than any like unit tests. Unit tests too, okay, they break when you do refactoring, but they're usually easy to fix.
So, Ahmed, how much time have you spent with DVCS connector UI tests in
Yeah.
the last couple of weeks?
1 week.
Yeah, that's
Solid-
all.
Yeah.
Solid week doing
So it's a
nothing
1
other
week
than
of-
dealing
yeah.
with a WebDriver version was updated or something else happened, so cascading
So,
changes.
so at some point, you may ask,
Or depending on the DOM of other product which is GitHub. So for example, they can change the tag or something.
yeah.
Now testing people
Yeah,
can
and also
do-
yesterday we were talking with Eric. I think that in dev status also many of the fixes, actually of the flaky tests, are fixed by the Alleluia retries, right? So if we remove those stages, how many flaky tests we will have?
Yeah, so at some point you wanna ask yourself, like, okay, I'm fixing a bug, say, and I'm writing, or I don't know, introducing a feature and writing a WebDriver test to cover some edge case that may cause a bug or not in the future, may cause a regression. Is it worth, like, you know you're gonna, like, if you know you're gonna spend, let's say, a week or 2 weeks over the next year of someone's time to be maintaining that test, is it really worth adding it for the kind of versus the risk that you may introduce by not having a coverage or having only lower level coverage for it. So it's just something that I think we should be asking more.
Yeah, but to clarify, it's not that ask yourself a question, not whether to write a drive test. Always think about writing a test. It's just a question.
Yeah, I'm saying
Webdriver or
yeah.
on a lower
So a lot of times a lower level, even though it doesn't test the whole thing, will be better and lower cost and still acceptable coverage than say Webdriver test.
That's something you probably talk about in kickoff, right? You feature kickoff or story kickoff, you talk about what number and type of tests to write given what the code is.
Okay, should we have a short break before, or is everyone still good? I'm like that actually. I need a break.
There's the break.
No, okay, now let's go.
5 minutes.
Let's go through the first part of the Webdriver theory, and then have a break maybe, and then go through. Then we'll do the second part and maybe some practice. Okay. So now we're going through to the actual Webdriver. So first the agenda. First a bit of an overview. So how. So it's gonna be very focused on Atlassian Selenium because that's what we're using to write tests. Kind of explain how it works. So it's gonna be a mix of like more general principles, but then also a very specific Atlassian Selenium specific examples. So first an overview, how like just explain basic concepts how the Webdriver tests in using Atlassian Selenium work and what's the main APIs in Atlassian Selenium and why do they exist, because I think most of you have seen things like tested product and page binder, but maybe you're like asking what the hell is that for even. Then we're gonna go specifically about a little bit about page objects. I guess most of you understand the concept and know why we're doing that, but nevertheless I'm gonna remind you why we're doing that. And kind of how to build them, because I think there's a lot of confusions about like, okay, let's build page objects, but how to do that. And then we'll kind of go a bit more higher level and talk about like principles and smells, so like more general stuff with maybe some concrete examples of how that looks in practice. And then we will jump to the code, so we'll have like a practical workshop, which will be basically me. I think it's not very realistic that all of you will be like working on code, so I'll be coding, or maybe just jumping between tags in my Git repository to show you how things improve over time automatically. And yeah, and that's pretty much it. And then just a short summary to summarize the whole thing. Depending on how much time we have, I have kind of one code example of how race conditions work, if I manage to finish it during the break, because it's kind of half finished. And then one like a full example of, I went through a couple of page objects in the DVCS connector and kind of tried to improve everything that was bad about them. Which was quite a lot. Okay, so the overview. Just maybe to give you some picture, if you didn't know that, how the dependency tree for your Webdriver test looks like. So starting from the top, that's where you have Webdriver tests, and Fusion Webdriver tests, say the ones that run in Jira plugins, they depend on Atlassian Jira page objects, which is product-specific Jira library of page objects that also transitively gives you Atlassian Selenium, which is our kind of framework for building page objects and running Webdriver tests. And then the Atlassian Selenium has two main, I guess does two things. One thing is it will get the right browser and start it for you. So basically that's why when you click, I'll to run a test, it just automatically opens the browser. So it actually goes and fetches it from Maven and kind of unzips it and shit like that. So you don't have to worry about having a browser installed anywhere up front to run your tests. And then the other thing is, it depends on the actual Selenium project, which is also known as Webdriver, which is basically the browser automation framework that we're using, and then provides some APIs on top of that to kind of hopefully make it a bit easier to use. So Selenium, like, that's the lowest level, kind of, that's the browser automation API that has, you know, very kind of low level APIs to interact with the browsers. So for example, going to a web page and then finding some elements on the page and then clicking them or doing whatever you need to do with them. So that's at the very lowest level. Webdriver, as you probably all heard about it, it's probably the industry standard now for browser automation. I think that they actually are standardizing it as a www standard, some sort of standard. It's basically theoretically capable of automating like any browser, like Chrome or Firefox or IE or Android or iPhone and so on. It's doing that by actually, well, depending on the browser that it's trying to automate, it has different approaches to it, and then it has this one common API that is supposed to work against all the browsers. In practice, because it's so complex, it's getting it mostly right, but it's often enough not getting it right that we get a lot of bugs and a lot of broken tests because of some bugs in Selenium. So yeah, that's the optimistic, very happy state of things.
Do we contribute to Selenium much, or are they open to contribution?
They are open, but I don't contribute. It's just the bugs are usually very low level. Like you would have to get and start like changing their Firefox plugin or the. So the way it actually works is it starts up a server in between, or a kind of, for every browser it has like a service thing. So it's a separate process that actually interacts with the browser, and then it has like a remote server that the test process sends just commands to the server, and the Selenium server translates it into the actual browser commands. So it's pretty complex technology, and depending on the browser, like for Firefox, it's just a kind of JavaScript-based plugin. And I've never. If you're happy to contribute, go ahead. But I haven't. I can give you a link to a GitHub repository. But I've been usually